all the pest developers today to know their surroundings to understand the benefits of container.
Good evening, everybody. We will wait for 5 more minutes and then start with solving the problems. So let's start with question number one. I have few multiple choice questions and then we can start solving the problems. So the question number one is which among the following statements is true for sterilization operation? Option A is heat generated in bioreactor is generally due to heat of mixing and heat of metabolism. B is sterilization and controlling reactor temperature are the two most common heat transfer application in bioreactor operation. Option C is in batch sterilization operations. The holding time THD can be minimized by taking into account of the cell restriction during heating and cooling periods. Option D, in continuous sterilization, the time of exposure to the desired sterilization temperature is independent of the length of the pipe and holding section. What would be the answer? I hope you have already finished the week 6 and lectures and assignment. So I hope you know the answer for this question. Okay, so the answer would be A, B, and C. So the heat generated in a bioreactor is, of course, generally due to the heat of mixing and heat of metabolism, and so the option B also, which is the reactor temperature and the sterilization and controlling the reactor temperature are both the two most common heat transfer application. And just in case of batch sterilization operation, the holding time can be minimized because uh, cell restriction occurs during heating and cooling periods. So the options which are correct are A, B, and C. So the question two is during sterilization, the operating temperature and time depends on the kinetics of inactivation of the cells. Is this true or false? The statement is true or false? It's actually true. The question number 3 is, consider an enzymatic system immobilized in spherical beads following Michaelis Menten kinetics. For this system, an internal diffusion limits the enzymatic reaction rate. The apparent Vmax and Km deviate from their respective intrinsic values. Uh, does this statement is true or false? Is it true or false? The answer is true. So, which among the following is not true for continuous sterilization using steam injector? So, the option A is the continuous steam injector injects steam directly into the unsterile broth. Foaming may occur when continuous steam injector is used for sterilization. And option C is direct contact of the medium with steam does not require elements to be made for the dilution caused by the condensate. So, what would be the answer? The statement is, we have to choose a statement which is not true for in case of continuous sterilization, which uses steam injector. So the answer is C, where the direct contact of the medium with steam does not require elements to be made for the dilution caused by the condensate. So this is the opposite of what the actual statement is. So question 5, determine the correctness or otherwise of the following assertion A and reason are. The assertion A is, for any sterilization operation, relatively high temperature with short sterilization time is the most preferred mode of sterilization. And the reason R is, the mode of sterilization with high temperature with short sterilization time favors the rapid killing of vegetative cells and spores with minimal denaturation of nutrient components present in the liquid medium. So the options are given below. So what would be the answer for this question? So the answer is both A and R are true, but and R is the correct reason for A. So let's start solving some problems. So take a few minutes to read the question. I hope you have gone through the tutorial problems also. This would be similar to. So a continuous well-mixed bubble column is used for the conversion of tyrosine to dopa, and 3 millimeter spherical beads are used to immobilize the tyrosinase that catalyzes the conversion of tyrosine to dopa. So the Michaelis Menten constant for the immobilized enzyme is 5.76 gram mole per meter cube, and 20 gram mole per meter cube of tyrosine is fed into the reactor with desired conversion to be 97%. So the reactor is loaded with beads at a density of 0.35 meter cube per meter cube. The entire enzyme is retained within the reactor. The intrinsic Vmax for the immobilized enzyme is 1.285 into 10 to the power minus 2 gram mole per second per meter cube of beads. The effective diffusivity of tyrosine in the bead is 6.9 into 10 to the power minus 10 meter square per second. So the external mass transfer effects are considered negligible. So if the immobilization stabilizes the enzyme so that deactivation is minimal over the operating period. So these these we have to be careful when while reading the question so that the important details are not missed out. So the reaction follows first order kinetics, and the Thiele modulus for a spherical bead following the first order kinetics is given by psi 1 is equal to r by 3 square root of k1 by dA, and the generation relationship between the generalized Thiele modulus and the effectiveness factor for a spherical catalyst following for first order kinetics is also given. So what was asked is A, we have to determine the generalized Thiele modulus for the spherical bead. B, to determine the internal effectiveness factor. C, to determine external effectiveness factor. D would be the dilution rate, and E is the reactor volume needed to treat the 25 meter cube of tyrosine solution per day. So first, please read the question and note down the given values. Then we'll start solving the problem. Let's start writing down the given values. So the diameter of the bead is 3 millimeter, which can be 3 into 10 power minus 3 meter. So if D is 3 mm, and then we can calculate R, which would be D by 2. So it is around 1.53 into 10 to the minus 8. So the Michaelis-Menten constant Km is given as 5.76 gram moles per meter cube. Our intrinsic Vmax is 1.285 into 10 power minus 2 gram mole per meter cube of beads. And your effective diffusivity, which is dA, is 6.9 into 10 power minus 10 meter square per second. So we have to calculate K1, which is given as Vmax by Km. If we calculate this K1 value only, we can substitute it in R side. Sorry. So the formula shows we were asked to calculate a generalized Taylor modulus for the spherical bead. We'll consider this formula. So now we'll find out this and then we can substitute it here. So what is Vmax? It is into 10 power minus 2 divided by your Km, which is 5.76 into the power. This is gram mole per second into here, and this is gram mole per minute. So this would be around 2.23 into 10 power minus 3 second inverse. So this can be substituted here. No, sorry, so R is we found it is 1.5 into 10 power minus 3 meter divided by 3 into root of your K1 is 2.3 divided by your D effective diffusibility is 6.9 into 10 power minus 10. Just for this. So what would be the answer? So what would be the answer? The answer would be around 0.899. So this is the answer for our generalized Taylor modulus. So what is the second question, which is determine the internal effectiveness factor. So how do we determine the internal effectiveness factor? We got your formula here. So let's write down the formula. 1 by 3. We'll first substitute whatever we know. So how do we calculate hot cot H? So it is a hyperbolic function, so we have to calculate this with the scientific calculator. So in your calculator there will be a function called HYP, which denotes hyperbolic function. If you go there and then select tan, it will give you you will get a function of tan H. So if you get tan H from tan is actually inverse of cot, right? So tan H you will get from there, you can do 1 by tan H, which will give you cot H. So if you put that function to action, then you will be able to solve this. The answer would be around 0.17. So I will repeat about the cot H hyperbolic function. So to calculate this value, use a scientific calculator and select the hyperbolic functional key, which will be HYP. Please press that and then select tan. So you will get a function of tan H. So if you do 1 by tan H of your value, then it will give you the value of cot Hx. So this is 7.71. So we have to determine the external effectiveness factor. And if you look at the external mass transfer effects are negligible, it's given. So if we consider the external mass transfer as negligible, then your external effectiveness factor, which is Ne, is going to be 1. Patel Bhavik, can you please mute your conversation? Thank you. So the question D is, we have to determine the dilution rate. So for the to determine the dilution rate, what is the formula? I hope you guys remember from the initial weeks. I think maybe week 2 or 3. What was the formula? So let's calculate our dilution rate. To get the dilution rate, let's see what about the substrate is being given. So it's being stated that your conversion should be 97%. So let's check whether any initial, yeah, here it is. So the initial substrate concentration, which your substrate is tyrosine. So initial substrate concentration is given as 20 gram mole per meter cube. We have both X and S naught value. So the formula, if you remember, X equal to S naught minus S, your final substrate concentration divided by S naught. So we know X is equal to 97%, which is equal to 0.97. So if I substitute this, 0.97 is equal to your S naught is 20. 20 minus, look, what will happen? 0.97. to calculate your you can calculate based on your um, the formula, which is d of s naught minus s equal to v dash. From this we can calculate your dilution rate, but before that we have to calculate this. So to calculate this, how we can calculate, the formula is actual reaction rate is given by your total effectiveness factor to Vmax is divided by Km plus S, but your effectiveness factor total is given by, we found out it as 0.7, and your this is internal, means NIL plus NEL, internal and external, one which is 1.71. If you substitute it back here, would be dash is 1.71. What is Vmax? Vmax is what? 1.285 into 10 power minus 2, and instead of Km is 5.76, and the S value we just found it as 0.61 into 1.285 into 10 power minus 2 into 0.6 divided by 5.76 plus zero point 0.6. So what would be the answer? If we find this V dash, which is actual reaction rate, we can take this and substitute it in your this equation and get the value of the dilution rate. So the answer would be V dash is equal to 1.7 divided by, this is how much? Sorry, it is actually n total is n intrinsic into external factor. It is multiplied, it is not plus. That is the case, it is 0.0860 into 10 power minus 2, which can be written as here. So it is converted as 8.607 into 10 power minus 4. So if we substitute, this is at steady state of transfer of substrate reaction rate. The formula which I had given before, which is d of s naught minus sf, put away dash. So if we put 0.607 and 10 power minus 4 divided by s naught minus sf, which is 8.607 and 10 power minus 4 divided by 20 minus 0.6, 0.4 something, 10 power minus 5. second inverse. This is your D. So you have just found the value of D, which is your dilution rate. So now what was the question asked? The fifth question. Determine the reactor volume. We were asked the volume in terms of meter cube, and which is needed to treat 25 meter cube of tyrosine solution per day. So 25 meter cube of tyrosine solution means what has been given already? What does 25 meter cube means? The volume of substrate to be used per day is given, which is 25 meter cube. So how can we calculate the reactor volume? Simple F by V only, which is V is equal to F by D is equal to F by V, right? We know the dilution rate, so with this we can calculate. F was what? 25 meter cube per day it's given. So we have to convert it in terms of seconds because your D is in seconds, so that we can cancel things out. So to do that, then V is F by D. F is 25 meter cube per day. If that is the case, F is equal to 25 meter cube per 24 hours into 36 seconds. So if we substitute it into this, answer would be around 6.5 meter cube. So the volume of the reactor would be around 6.5 meter cube. That's all this one is about. So, so this is the next question. So please take few minutes to read the question and then we will start solving the question. I think it is a very simple problem compared to the previous one. If you have graph sheet, we can solve it in graph. Otherwise, you can note down the how is it being solved, and then you can try solving it in your own using your graph sheet, or you can use your Excels to draw the graph. Sorry, graph. So let's start solving the problem. Alright, on the given values, your radius is what is given? Dia is given, which is 8 mm, which is your radius is d by 2, which is 4 into 10 power minus 3 meter. And what else is given? It is effective diffusivity, it is dE is 2.1 into 10 power minus 9 meters square per second. And so the enzyme is immobilized in 8 mm diameter across beads at a concentration of it is concentration of 0.018 kg of protein per meter cube of gel, and 10 beads are immersed in a well mixed solution containing 3.2 into 10 power minus 3 kg per meter cube of substrate. Okay, so the substrate is given, how much of substrate, and 10 beads, the number of beads is also given. So the effective diffusivity is 2.1 into 10 power minus 9 meter square per second. The kinetics of the enzyme can be approximated as first order with specific rate constant as 3.11 into 10 power 5 second inverse, which would be your K1. The mass transfer effects outside the particle are negligible, and you were asked to plot the steady state substrate concentration profile as a function of particle radius. So, as it is given that mass transfer effects outside the particle is negligible, we can take, that means in the absence of any external mass transfer effects, we can take your concentration of substrate solution as 3.2 into 10 power minus 3 kg per meter cube. So we have to calculate volume per bead. How much is the volume? You can multiply it by 10 to get the volume for 10 beads. So what was asked was your concentration of your substrate in terms of your particle radius. So we'll start solving. So these are the given values. So to calculate the volume per bead, what is the volume of a sphere formula? It's what, 4 by 3 pi r cube, right? So r, you know the r value, which is 4 by 3 into 2.17. கிளாஸ் எடுத்துட்டு இருக்கேன். So 2.17 into your r value is 4 into 10 power minus 3. So if you solve the values, it would be what? 2 point, what would be the answer? 2 point something, right? 2.68 into 10 power minus 7 meter cube. This is the volume of one bead. So the how much is the volume of, so 10 beads, therefore the volume becomes 2.68 into 10 power minus 6 meter cube. Okay, so the amount of enzyme which is present in these beads, how can we calculate? The number of beads into your concentration. That would be 2.68 into 10 power minus 6 into your 0.018 kg of protein and gel, which is 4.83 into 10 power minus 8 kg. So we have to calculate our K1 value, which is 3.11 and 10 power 5. 4.83 into 10 power minus 8. What would be the answer? It is around 0. We got the K1 value also. I have to calculate. So this is the formula. This is what is being asked. The profile to get the, this is the formula sign it. I hope you remember this. So how do we calculate sin h? Sin h is e power of x minus e power minus x divided by 2, right? Positive substitute the radius we know. It's K1. K1 is 0.015 and your D is what? 2.1 into 10 power minus 9. And what is the value of R? I think it is 4 into 10 power minus 3. What would be the value of this term? You can substitute it here. This is the one which we need. The graph should be in terms of this and this. So this would be around 10.693. If this is the case, we can do the sin h of 10.693. For that, what do we have to do? E power of 10.693 minus e power of minus 10.693 divided by 2. How much is the value? It's about 2.2 10 power 4. So you have now calculated this entire term. So if this kind of question is being asked, you will be given a substrate concentration as well as your particle radius will be provided. what you have to do is you have to find, sorry. So now this term you have found, right? I will explain. So what you have to do, you have to weigh, these are all will be constants, and based on the R provided, you have to calculate this value, tabulate it, and then form a graph. So if we do that, concentration versus your radius, this this would be in kg per meter cube. And the graph will go like this. So based on your um so this would be the profile of your, so this is the profile of your steady state substrate concentration as a function of particle radius. So if you were given, you will be given the radius value, different radius value. So based on that, you have to calculate the concentration, and then if you, so for calculating that only, we have found all these things. So as the session doesn't, we cannot explain, like I was not able to inform you guys about graph sheets. We will not be doing that. So I'm just explaining the procedure. So by substituting all this, you will be able to get your different CA values. If you plot your CA versus R, then you will get a graph like this. So this is the profile which was asked. So by looking at the graph, how, what do you mean? It is the substrate concentration drops rapidly inside the particle. So as it to reach which is 0 millimeter from the center. So let's take 2 minutes to read the question number 8. This is baby hamster kidney cells are, it is mammalian cell culture is basically immobilized in alginate beads. The average particle diameter is 5 millimeter, and the rate of oxygen consumption at a bulk concentration of 8 into 10 power minus 3 kg square meter cube is 8.4 into 10 power minus 5 kg per second meter cube catalyst. So the effective diffusivity is given as 1.88 into 10 power minus 9. So we are asked to assume that the constant oxygen concentration at the surface of the catalyst is equal to the bulk concentration, and that oxygen uptake follows zero order kinetics. So you were asked whether internal mass transfer effects are significant, and what reaction rate would be observed if the diffusional resistance were eliminated. So how do we start solving the problem? So basically it's a small, very small problem. So take a few minutes to read the question, then we will start. So if you want to access about the internal mass transfer, we have to calculate the observable Thiele modulus. And so in case of spherical geometry, it is given as Thiele modulus is given as R by 3 your whole square rate absorbed divided by the your diffusivity into concentration of the cell. So if we do the calculation, your R value is given as 5 mm, right? So 5 into 10 power meter is diameter. So R is 2.5 into 10 power minus 3 meter. So if you, what else we, diffusivity is there, so this can be done. And what is the concentration? Bulk concentration is 8 into 10 power minus 3, that is also there. The absorbed rate is what? Yeah, the rate of oxygen consumption to see. So we have everything which is needed to solve this equation. So we'll just substitute it and find the absorbability modulus. We do that. This is I is equal to 2.5 into 10 power minus 3 divided by 3 whole square into 8.4 into 10 power minus 5 divided by 1.88 to 10 power minus 9 to 8 into 10 power minus 3. If you solve this, we'll get the value of psi. What will be the answer? 0.4 into 10 power minus 5. So what was, or the internal mass transfer effects are significant, your Thiele modulus is greater than 1, right? So what does it mean? So if a Thiele modulus of greater than 1 means what? whether your internal mass transfer effects are significant or not significant. So basically your Thiele modulus is your reaction rate divided by your diffusion rate, right? So if it is more than 1, means your reaction rate is more. So what would be the answer for B? What is asked for B? What reaction rate would be observed if the diffusional resistance is eliminated? So in case of your spherical catalyst and zero reaction, if your internal diffusional restrictions is being neglected, then we can calculate 9 effect on factor of internal effect on factor Ra observed divided by R star A is to be your 8.4 into 10 power minus 5 divided by 0.4, that would be around 2.1 into 10 power minus of kg per second meter cube of catalyst. So uh, if our diffusion resistance is being eliminated, then the observed reaction rate would be 2.1 into 10 power minus 4 kg per second meter cube. So this is the last question. So take few minutes to read the question. I'll read the question and then we will solve the problem. So the invertase from Aspergillus oryzae is immobilized in porous resin particles of diameter 1.6 mm at a density of 0.1 micromole enzyme per gram. The effective diffusivity of sucrose in the resin is 1.3 into 10 power minus 11 meter square per second, and the resin is placed in a spinning basket reactor operated so that the external mass transfer effects are eliminated. So at a sucrose concentration of 0.85 kg per meter cube, the observed rate of conversion is 1.25 into 10 power minus 3 kg per second meter cube, and the Km value for the immobilized enzyme is 3.5 kg per meter cube. We were asked to calculate the effectiveness factor N nu and also to determine the true first order reaction constant for the immobilized invertase enzyme. So take few minutes to read the question and then we will start solving the problem. So we'll start solving the problem. So first let us note down the given values. So we were given the diameter is 1.6 millimeter, which is 1.6 into 10 power minus 3 meter. Here R value would be d by 2, right? So if it is that is the case, 0.8 into 10 power minus 3 meter. What else is given? Your diffusivity. OCA is 0.85 kg per meter cube. Our observed rate is 1.25 into 10 power minus 3. And Km value is 3.5 kg per meter cube. We were asked about the effectiveness factor. So as the external boundary layers have been eliminated, which is provided here, external mass transfer effects are being eliminated, then means your concentration of the substrate present in the bulk is equivalent to the substrate present in the surface of your immobilized catalyst. So if that is the case, you can assume Ca is equal to 0.85 to kg per meter cube. Okay, so as your external mass transfer effects are eliminated, it can be taken as 1. So we can calculate the beta. How do we calculate beta? If you remember, beta can be calculated from your Km value and your Cas, which is 3.5 divided by your Cas 0.8, right? What is that? Around 4.12. So from the value of the beta means the reaction kinetics can be considered as first order. So we can now calculate the observed Thiele modulus for your spherical immobilized beads. So if we do that, this is the this figure is an internal effectiveness factor as a function of the Thiele modulus for its spherical geometry and first order, and zero order is being provided here. We can use this to calculate our values actually. So if we calculate our Thiele modulus, it will be for spherical geometry R by 3 the whole square absorbed rate divided by your T into Cas. We do that, it's 0.8 into 10 power minus 3 divided by 3 the whole square. Rate was given as 1.25, what is 1.3 into 10 power minus 11 into 0.85. Please solve this. So what would be the answer? The answer would be 8. Mm. So your Thiele modulus is observed Thiele modulus is 8 from the graph which was given here with the data sheet. You can calculate, see it is your Thiele modulus of 8 is around here. So your beta is actually first order, that's what you calculated. So if you do that, you cut the figure here, go back here. This is point 1, right? This is point 2, point 3, point 4, point 5, point 6, point 7, point 8, point 9, 1. So it was around point 0.12 or 13 we can take. We will take 0.12. So we can decide as your effectiveness factor as a function of given, right, as a function of the observed Thiele modulus for spherical geometry in first order. So from figure we found your internal effectiveness factor as 0.12. So now the equation, how does it become? Your total in effectiveness factor is Ni into Ne, which is internal and external. So internal we calculated as 0.12 from the graph, and external is considered as 1 due to external mass transfer as limitations has been removed or neglected. So this would give you the total effectiveness factor as 0.12. So we have just calculated the effectiveness factor, which is 0.12. It's not, it was not asked whether it is internal or external. So you have to calculate the total effectiveness factor. So now the question B is to determine the two first order reaction constant for the immobilized enzyme invertase. So how do you calculate that? Star A is RA absorbed. I just had cross multiplied it actually. The formula is R star divided by R star. Yes, right. So if we substitute this, it is what 1.25 into 10 power minus 3 divided by 0.12 is 0.0104 kg per meter cube seconds. So in case of first order kinetics, how do we write a rate constant? Rate is equal to K1 into the concentration, right? So for first order kinetics, raster AS will be given as K1 CAS. Therefore, K1 will be found by CAS by, no, it will be found by R star AS divided by CS. Here R star value is just found at 0.0104 kg per meter cube second divided by C star A. CAS is 0.85, which is kg per meter cube. If you cancel this, the answer would be what? It is 0.0 122 second inverse. So it was asked to determine the true first order reaction constant. which that is K1. For the immobilized invertase, we just found the K1 value. This is the two first order kinetic constant for this particular enzyme, which is immobilized. Here, according to question, it is invertase. So that would be about the class. So this we have solved some problems on the mass transfer of heterogeneous system. So I hope you have completed your assignments on week 7, and I do hope that the session was useful as you just have submitted your previous 6th week assignment also. So if you have any doubts, please mail me to the mail ID provided there, and also mention in the discussion forum about if you have any doubts in the live session, please mention in the discussion forum. I hope the PPTs are available and accessible. If you have any doubts, you can ask.
No, ma'am. Thank you.
Yeah, thank you, Surya.
டேய், கடலை வச்சுட்டு ஒரு நூடுல்ஸ் வாங்கிட்டேன். நூடுல்ஸ் செஞ்சு சாப்பிட்டுக்கலாம் வந்துடு வீட்டுக்கு. எதுவும் வாங்கிடாது. எஸ் ஆஃப் கோர்ஸ். ஃபயர் இருக்குது. சத்து. ஒரு கிழங்கு, தோசை மாவு 2 கிலோ, அப்புறம் 10 முட்டை. பால் நான் வாங்கிட்டேன். ஆமாம், அரிசி வாங்கிட்டு வந்து. மண்டேன்னு கேட்கல. நீதான் வெளில போட்ட சொன்னிய பாருங்க, வந்தாரு. நீ போன் பண்ணி சொல்லு. அப்புறம் நீ எக்ஸாக்டா எங்க இருக்க? அப்புறம் இந்த கடைக்கெல்லாம் போய் கூட கேட்டாரு. ஓகே பாய்.
So thank you for joining the session. This should be the end of the session. I hope I was able to solve the related problems. Um, so if you have any doubts, reach out to the discussion forum, ensuring it is from the Friday session of the live session. We'll meet in the next class. Thank you.